at the end caps, okay? And so if you're going to put a barrel together, you need one body and two end caps to put a barrel together. Right, keep that in mind as we go through and look at this. So you're making barrel bodies over here, you're making barrel end caps over here, and then you're taking a body and two end caps and you're putting them together and you're putting them in the warehouse. Yeah? The circles are the workers, okay? So in order so that you didn't just have to look at a chart and go how many workers are in each. The circles are how many workers are in each of those little cubicles. So if you look at it right here, when we're doing whatever the hell rough fitting is, we've got a cubicle in there that's doing rough fitting. There's two workers in that cubicle, right? There's two workers in that cubicle, two workers in that cubicle, and two workers in that cubicle. So later on when we're doing labor utilization, do you agree with me that there are 8 workers in that room? And therefore the labor utilization is going to be 8 people times whatever the bottleneck rate is that we're running the system at, divided by whatever that room is capable of doing, correct? All right, what is this weird little drawing right here? That's one person running back and forth between these two things. So that one person, this is toasting. If you'd have watched the video, you'd see the little toasting and how this stuff all works, okay? So there's one person that's got 2 toasting stations, all right? And so they're running back and forth and making sure the toasting is going on. So when we're doing this room, how many workers are in that room? 4, okay? And when we're doing a labor utilization, it's going to be 4 times the bottleneck divided by whatever that room is capable of doing. Let's do another couple things and let's look at the solution. Remember that I bit? There's that whole question of I, how many can be in there at one time? So here's the rule for our class. Unless I tell you otherwise, and I will tell you otherwise sometimes, unless I tell you otherwise, there is always only one flow unit per cubicle. Unless I tell you otherwise. I did not tell you otherwise on this. So, how many flow units are in this room right here? There's 1. Does it matter that there's 4 workers? No. That matters when we're calculating labor utilization later on, but it does not matter in terms of I. I is 1 flow unit in there, correct? So I give you T down there. See, it's 4 minutes per barrel down there. So we got the I, we got the T, we can figure out the R for that room, correct? Okay, let's do this one. What is I for this one? Does it matter that there are 8 workers? No, it does not. There are 4 different cubicles. Each cubicle can have 1 flow unit, unless I tell you otherwise. So I is 4. Okay? It takes 20 minutes. I equals RT. We can figure out what the R is. Cool? So you see how that's going to work on all this stuff? So I've got the pictures of the number of workers. You can see how many cubicles. If I don't tell you otherwise, there's 1 flow unit per cubicle. So let's do it. What does that solution look like? Well, nice thing about that is I've provided the solutions to you. So that is the 2019 exam solution. There it is. And let's look at this. It's exactly like what we just did. Take a look at this. So remember.
Can you make it a little bigger?
Yeah, let me try. Is that a, I can't see, is that a plus? All right, let's do that and then we'll just scroll around. Okay, so in this room, that is a room, right? That room has a nameplate on it, I, R, and T. I look inside the room, there's only 1 cubicle, the flow unit is barrels, I told you that in the exam, okay? So there's 1 barrel in that 1 cubicle. The time, if you remember, was 4 minutes. So I equals RT, that becomes 15 barrels per hour. Cool? And you agree in principle we can do that on all of these? So there are 4, there's 1 flow unit here, 1 flow unit here, 1 flow unit here, 1 flow unit here. So that's 4 barrels. The time was 20 minutes, so we calculated it as 12. So we go through and we do that, and we now have a nameplate on all of these rooms. Those rooms are making barrels. So the flow unit for those rooms was barrels. Okay, now let's go down here. Before we look at oak barrel down here, let's go down here. Now remember, these are making end caps. All right, so let's just make the flow unit end caps right now. Let's not worry about how many end caps or anything. This will all take care of itself. Don't outthink it. It will take care of itself if you just follow the process. So, I look inside this room. There are 2 cubicles. Each cubicle is working on 1 end cap. The flow unit is an end cap. So, I is 2 caps. The time is 4 minutes per end cap. So we can calculate the flow rate is it can do 30 caps an hour. And we can do the same thing here. 1, 2, 3, 4. There are 4 end caps. The time is 10 minutes, so we can do 24 end caps per hour. We cool? All right. Now the only thing you need to do is later on when we're figuring out where the bottleneck is, we're making barrels. So we need 2 end caps for every barrel. So you can turn 30 caps per hour is the equivalent of 15 barrels per hour. Yeah, there you go.
Is that on campus?
Yeah, you have all this. So just so that you're clear, I want to make sure you understand this. If you go onto Canvas, okay, and you go to Files, under Files, you have every one of these things right here, and just scroll down and you'll find out under Files, right here, you have the Fall 2019 exam, okay? And remember, your homework is not the 2020 exam, it's the 2021 exam. So you have the 2021 exam solution. But this ain't my first rodeo, right? I've been teaching for 31 years now. It's a false economy to go directly to the solution, because then you didn't try it. Try it, and then if you get confused, look at the solution, and that works out great, okay? But don't go directly. You're saving 30 minutes now, and you're not understanding it later when you have to be able to do it, okay? So is that clear? You can get this on campus, okay? All right. So, everybody cool on how this works? So we're doing the same thing. You go through here, and we're looking, where's the bottleneck? Well, that's 15, 12, 10.67, 15, 10, 24, 15, 12. Looks like that 10 right there is the bottleneck. So do you agree this process can do no more than 10 barrels an hour? And the bottleneck is what's happening in the ring tension and final assembly. Yeah? Okay? It's the same thing we just did, just a little harder. Okay?
And it doesn't matter that each one is in its own.
Doesn't matter at all, because you gotta go through everything, right? And if one of the houses you have to go through is slower than the other house, you're stuck. Okay? All right, so there's that. So where's the bottleneck? It's the ring tension and final assembly, 10 barrels per hour. Now, I'm gonna be asking you on your homework the same thing. How many can you make in a standard month? Okay, and I give you all the information, 10 hours a day, 20 days a month. So this is literally a rate problem. Now, the engineers in here, you guys like to say, okay, I started empty, it takes a while before the first one gets out, right? And then I have to shut down early before the last one gets out. Those are startup and shutdown effects. Don't do that in here. That's way more complicated than you need to do, okay? So Nicola, don't do it.
No problem.
Jeep, don't do this, okay? All right?
No problem.
I am literally just wanting to know the maximum unachievable upper limit on how many you can do. You know why? Because next class we're going to do cost structure. And when we plot cost structure, we look at all the possible volumes we need. I just need to know the max we could ever do. So that's all this is. So literally, 10 hours per day, 20 days per month, 10 barrels an hour, 2,000 barrels a month. What's the fastest it can get through this process? Now it does matter, right, that these things are in parallel. Because you have to say, you know what the easiest way to do this is? Imagine an empty process. It's empty. Now you turn it on and you run as fast as you can. How long to get the first one out? That's the easiest way to think about it. Just turn it on. How fast can you get the first one out? So you have everything empty. You turn it on. There's no waiting. The triangles don't matter. Do you agree that the first barrel body is going to get over here in 15 plus 12 plus 10.67 plus 15? So 30, 42, 52.67 minutes. Everybody agree? The first barrel body will get over in 52.67 minutes.
No, those are your rates.
Oh, you know what? I'm looking at the wrong damn thing. Never mind. Yeah. My bad. No, it's flat out wrong, okay, all right, flat out wrong. It's 4 plus 20 plus 45 plus 4, okay? Everybody cool? So what is that? 24, 28, 93. So 93 minutes is when the first one comes out. Agreed?
Yeah.
Now this guy can't start anything until we get 2 end caps out of here, right? So how long does it take us to get 2 end caps out? It looks like 4.
It's 73.
It's a lot less, so it doesn't matter. The other one matters, right?
73.
Okay? 73 versus whatever the other one was, okay? All
On
right?
top is 73.
Oh, the top is 73, and this one's faster.
Round
It's
14.
Guys, what the fuck is 4 plus 20? It's 73, okay?
We're not
Okay,
going
we all suck.
How many
Okay?
to add 4 numbers together?
You know what, I've already got the answer down here. Okay,
Oh my
basically,
God.
I didn't even, it sure ain't 90, because the whole sum is 84, okay? There's the 4 plus the 20 plus the 45 plus the 4, right? And that took longer than getting 2 caps out here, so they don't matter, right? They don't matter in this calculation, all right? So after you've gotten through these 4 plus 20 plus 45 plus 4, then it's another 6 plus another 5. And that's the fastest you can get through, 84 minutes. We cool?
Yep.
All right, give me one more second. What's the steady state labor utilization assuming adequate demand? All right, we're doing the same thing we did, right? The number of people and that. Notice, okay, even though Coco wants to fire all these people, we still have to pay the people down here, right? Okay, so when we're calculating labor utilization, I need every room and all the labor in every room, correct? Okay, so if you go through and do it, you'll see it's that same way. All right, it's 4 in the first one, the bottleneck's 10, but it could do 15 and so forth all the way through. Is that clear?
Yep.
You can't answer this one yet because we haven't done the goal. Okay, so don't worry about that one yet. Okay? Is that clear? So what's your homework? Let me say, Anna, don't go yet. I'm saving you time. All right? Your homework is the 2021 solution. All right? Your first homework. The only thing I want you to notice from the first homework is this. You see that gray box up there? Remember I said, unless I tell you otherwise, there is only one flow unit per cubicle. That gray box is telling you otherwise. That gray box, if you read it, says, each anodizing station processes a batch of 5 scope bodies at one time. Okay? That's all you need to know. Don't, engineers really outguess themselves on this one, because then they want to divide the rate. Don't do that. It takes care of itself, okay? Each anodizing station processes 5 scope bodies at one time. There's one, there's another, there's another, there's another. What's up? 20. Don't do anything else. How long does it take? It takes 60 minutes. So it will take care of itself. You don't have to divide the time by anything or batch it or anything. It takes care of itself. So, if I is 20 scopes, and I told you that the time was 60 minutes to do an anodizing bath, then do I equals RT and it will work. Other than that, it's exactly the same thing we just did. Okay? No more than an hour on this homework. That's all I want you to spend on it. Go home, try it. It should not take you more than an hour. If it does, that's okay. Because the first thing we're going to do when you come back, next class, the very first thing we're going to do is go over this in detail and answer any questions. All right?
All right.
Yeah, we have to upload this. So I don't care whether you scan it, take a picture of it or whatever, but in Canvas, you go to that day and you upload it like you did in the other classes, okay? That's due our next class meeting. Okay? Our in-class example is the 29th. Your homework is 2021. Yep. Yep. Okay. Here. You guys know how to do the, hang on. You guys know how to do the Canvas thing, right? So here's the Canvas thing. So you're about to come to class for block 3. Look, submit homework number 1, process analysis. If you click on that, okay, first of all, there's the assignment if you want to download it there. I do, hyper organized, okay? So,